In Cebu, my first time to be in Cebu, but this is my third time in Philippines. And I want to thank Aline and Pastor for the great work that they did that enables me to be here. And I want to take this special moment and welcome you officially on this special program of Earthbag technology. You're most welcome. Yes. My name is Pastor Engineer Samuel Odyek. I'm from Uganda, and I have a family. I have one wife. I have one wife, and we have 5 children, and then also another 5 adopted children. So in total, I have 10 children at home. Yeah, I am pastoring a church called Jesus Christ Fellowship Ministry. But alongside pastoral ministry, I am also practicing engineering profession and specializing more in Earthbag technology. And I am doing quite a number of projects of Earthbag technology in Uganda and also other parts of neighboring countries that is outside Uganda. And I am here, the main reason why I have come here in Philippines is to do technology transfer, to also introduce this to the team in Philippines, and that is most especially in Cebu. So I want to thank Aline so much for also giving me an opportunity to be here and to make sure that today is our first day of this project. So let me first welcome her and then say something before we proceed.
Thank you, Pastor Sam. Pastor or Uncle Sam.
Yeah.
Uncle
Yes.
Sam.
Yes.
Basta nag-andi lang daw siya diri kay gusto niya ibalhin ang iyang bawaan dito sa Uganda para i-transfer lang niya kay gusto niya i-share di unsa nilaghi mo ang balay dito sa Uganda nga soil ra ang gigamit og sako. Naay lain materials pero dili gyud nga mas mahal kaysa sa iyang nabuhaton sa ang nagbuhat na sila og mga nga balay sa Nepal, sa India o lain nga African countries. So gusto nila i-transfer diri, i-share ninyo para makahimo pud mo sa inyong mga balay. Maski hinay-hinay lang pero bawaan ninyo ang teknolohiya. Okay?
Yes. So that's a little bit of what has brought me here. So I think let us start this program with a word of prayer. Yeah. Let us pray. Heavenly Father, we want to thank you so much for these great opportunities that you have given us, O Lord. We thank you for the love. We thank you for your favor. We thank you for your protections, O Lord, on each one of us, O Lord. I am so grateful, O Lord, that you have enabled me to reach here and you have blessed me with a good journey and they have received me here, given me warm welcome and good receptions, O God. I am praying that, Lord, everything that, Lord, you have brought me here to do, I ask you to give me wisdom and good understanding, Lord, that we will be able to do the transfer of this knowledge to your people. Yes. I pray that, God, you will be able to bless every team who are involved in this project, that as we begin this project, oh Lord, May you start with us, O Lord, and give us wisdom, O Lord, that we will be able to get all through, O Lord, this project, and it will be successful.
Yes.
We nullify any disruptions of the enemies against this project in the name of Jesus. And that, Lord, you will be able to protect everyone who are at the core team of making sure that this project runs successfully. We pray that you will protect them and give them good health and everyone. We give you praise and honor in Jesus' mighty name. Amen. 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 Yeah, so I want to talk to you about Earthbag technology. This has been the technology that has really lived for long. It's only that the way it is remodeled, it makes people think that it is new. But it is an idea that our forefathers had been using it long time ago. Even soldiers who are involved in wars, they used to use this simple technique to protect themselves. By the way, this is bulletproof. It is. Yes, bullet. It is bulletproof. Yes, because the armies used to create a form of bunkers where they run into it. Even if they throw bombs or bullets, cannot penetrate it. So they were using it to make bunkers, and they entered in it. But now, a team of engineers had to come up and remodel it, redesign it to fit in everyone's consumption. And that is fit for our residential building. And then it has been discovered that it has got a lot of advantages. And number one, it is earthquake resistance. It is resistant to floods. And then it is a heat resistance. We are going to look at it. It has numbers of advantages. Sandbags are used to construct an earth home. And you can design it in any shape. You can design in a way that you may not even use the roof, but it is in a dome form. Or you can design, raise the wall and roof it as well. And utilizing material fields from the building site is the first step. When it comes to this technology, soil becomes number one key materials that we use. And soil, we get soil for free, we don't buy it. When we will be going to site, you will go there and you'll see we have soil, the one that we have done from the foundation. Pastor has not bought it. What you only need is to have land, and that's all. So once you have the land, the soil you're going to dig from the foundation, you use it to fill in the foundation. So once you have soil as the key materials, then you will need bags. Pastor, can I have the sample of the other bag you gave me? Yeah. Yes. Okay. This is the sample of the bags. This is called polypropylene bags or polypropylene materials. It comes in different sizes. You can look at, that size is different from this. You can feel it. You can feel it. Yeah. This is made out of polypropylene materials, and the research says once this is buried under the ground, once it is covered, it can last for 500 years before it rots.
So,
Yes.
utang na siya sa
500 years before
500
it
years
rots.
bago siya madaog.
So now, let's
Die already.
So of course it will not get any of us. That means this building will live for
Long term.
generations. Yes, up to your fifth generation. Because we live 90 years or at most 100. You know. So that means your fifth generation will be able to still find what you have built today. It is good for remembering. And then, so now think about this. Once you have the bugs that cannot be destroyed or cannot be rotten, once it is protected, now you also have soil. Soil doesn't expire because we don't mix it with cement. So it is there to, even how you have used it, once you have filled it in the sack, it is there to stay. So you have now the bugs and the soil, and then there is another material called barbed wire. Barbed wires, we all know these barbed wires are galvanized. Keep it from being rusted. So these are three key materials that when you have, you are able to raise the entire wall. You see, in the foundation, we don't use cement, except in some other areas, maybe for buttresses, setting columns, like now what we are going to do there, because our building is on the slope ground. We are going to introduce some pillars to make sure that our foundation is strong. But when you're in the flat land, you may not necessarily need that. Unless the wall is beyond 3 meters, that's when you can introduce a pillar or buttresses in it. So, Earthbag are fire and waterproof polypropylene bags, and these tough bags can withstand the cold, the wind, and heat. These are the benefits that we all have in this technology. And then Earthbag shelters have been around for a while, though for how long it is unknown, because our forefathers had been using this before. They are typically utilized as places to hide during war, and prior to World War I, military infantrymen used sand-filled sacks to create bunkers. And Freitotto, a German architect, is claimed to have experimented with the Earthbag. Yes, the signal. So this technology, in 1995, the guy called, my signal is not stable, I don't know if the connection or, okay. So in 1995, Nader Kahili, the United Nations Development Program, UNDP, and the UN constructed 15 refugees shelter, giving the first test on this technology. And then this was done in Iran, you know, to test this. And the 15 dome cluster that was constructed might have been replicated thousands of times. So there's a lot of advantage that we have in this. One of the main advantages of the building Earthbag is of the design. You can design, have many designs, like storage, just like rooms, the dome kind of, any design, whichever design you want, you can, as long as you have a good architect or good engineer, will be able to design it for you. And then you can be able to have what you want. So it is not limited. It is not limited. That's the key area. And then it is cost-effective materials. How do we know that it is cost-effective? Number one, think about, we don't buy soil, okay? And yet it is the main key materials for this building. Soil, we get it for free. So, soil is just like the same as blocks or bricks. How much is the blocks here? 1. 14 pesos. And that is how much in dollars?
It will cost cents.
Okay. 25 cents. So now that is less than $1, right? Yeah. Now think about this. These blocks are made out of cement, which definitely expires. It has certain period of time. Once it reaches, this cement will definitely expire, and you will see cracks all over. And then think about, okay, it is made out of cement, sand, and then also labor were involved in making these blocks before you build. Bringing it in the site, you will again have to meet the labor cost of transporting it from where it is made to the site. Again, you have to employ people to build. Think about, we are talking about cost effectiveness compared to this. With this, you already have soil which is available. You are picking it from the site. You are not bringing it from anywhere. And then what you will only buy is the bags, and then the barbed wire. And then what you will need in the foundation, we have a lot of advantages. We may not be, you can be able to read through, but I wanted to go to explain the key parts. Where I have some simple diagram here. Are we all able to see? This is just the cross section of how our wall will look like. We have done, this is our foundation from here, this is the ground level. So when you look at the foundation, how the foundation is constructed, you start with putting the hard core. These are the symbols of the hard core. After putting the hard core, no cement. You don't need cement in the foundation because it has to be, the foundation should not be rigid, but it has to be only firm, but should not be rigid for easy movement. Why? Because this entire idea, it is earthquake resistant. When the foundation is shaking, the wall and the foundation must be able to move. Okay? It has to be flexible. But even if it is flexible, it doesn't fall. Because you have the barbed wire in between every layers that will be able to tie the entire wall together. So that's why we don't need any cement in the foundation. Then after that, okay, like now we are going to do on the sloping ground, we will need to provide the pipes to drain off water in case of any water log in the foundation. We need pipes that can, so we fix it under the foundation to drive water off from the foundation. Then you put hardcore like around 25 to 30 centimeters And then on top of it, you blind it with the aggregate, that is gravel. Yes, to make it well level. Once that is done, you are good to go to start building your wall right away. Okay? So, okay, our wall is not supposed to be from the ground level. It has to come even down all the way, like some 2-3 posts down here. Okay? We are going to do that. You have some question?
Yeah.
Please.
I have a question. What is the thickness of the foundation hardcore?
What is the distance? The thickness of the foundation.
The hardcore. The thickness of the hardcore.
The thickness of the hardcore is 25 to 30 centimeters. Yes. Yeah, something like this. Yeah. Got it? Okay. And then, so, think about this. When you're using conventional methods, we always spend a lot of money in cement going into what? Actually, most of the building here, even in other places, even in Uganda, a lot of cement goes into the foundation. Lots of money. We spend a lot of money, and we all know that the things that are really, really expensive in the building is actually the cement, the wires that we put, yes, the bars that we put in the foundation. So think about this. Your entire foundation, you have not used any cement. So you have cut the cost of cement, you have cut the cost of sand, even
The stone.
this. Okay, the stone, yeah, you will not definitely buy a stone. You will buy a stone and meet the cost of transportation. But you will have eliminated the cost of cement and the cost of sand and all its transportation as well. So it makes this cheaper. Actually, where we cut costs is from the foundation to the entire wall up to the roof level. Then the rest of other design goes the same. Like the roof, you will spend the same cost. Like the floor, you will spend the same cost. Even in plastering, you will spend the same cost. But where we save the cost is from foundation up to the wall, raising it. Why? Because you have got the materials, most of the materials, you get it for free. Like, you know, the soil. Soil actually deducts the major costs because we don't transport it. Unless now you are in a place where you can't get soil, whereby you need to transport soil from a different place to your land. Because there are some places the land is too small and you can't get soil from it, so you can be able to transport. It is allowed. It is allowed. Yeah. So, now, any questions surrounding our foundation? Any questions surrounding our foundation?
How many meters?
How many questions from the foundation?
Okay.
You can have like 2, 3. If you have the well-level foundation,
The surface is
if the surface is level,
no need to.
you can have only 3 down. Only 3 down. Yes. But if you have a steep, some other parts you will have like even 7 courses. Others can even be more. Yeah, it depends on the site where you are constructing this. Yeah, so like it's not fixed. But when you have a well-leveled site, you will definitely need to have all the 3 inside the foundation.
3 feet?
3 layers.
3 layers.
Layers.
Okay.
3 layers. Yes. Remember, you will have worked on because the foundation, the depth is usually 3 feet or 2.5. Yeah, 2.5. So if you don't have any question there, so when you come now to this, and you put your 3 layers, so these 3 layers that goes down into the foundation, if you are in a place that has got too much water, let's say maybe you are next to the swampy areas. I hope you understand swamp when I
No swamp.
you don't have swamp
Is
here.
it applicable in swamp?
Yes, you can.
How we can apply that in the swamp?
Yes, in the swampy area where in a place where you have a lot of water. Watery area. Let's just now put watery area. Yeah. So it is advisable that the first 3 courses that goes down, you use gravel fill inside the bags.
Gravel.
Yes, you use gravel for the first 3 layers. You use gravel fill in the bags. Then now, after the 3 layers, you can now use soil fill in the sand. The main concept is to prevent water rise into the building. In case of any water log in the foundation, it can never penetrate your upper wall. Yeah. So that's the key area. So when you look at how this wall look like, this is the bags, and then soil filled inside. This soil can be mixed with the gravel. When the gravel, the clay, it can be a combination as long as the texture, as long as your soil can hold itself and it can be compacted well, then your soil is good to go. Before I came, we tasked Brian to do some the test of the soil here, and he did a good job. And you guys, your land is also very unique in its own way. You guys have lime, and these limes are really good for this. The nature of your land is just like the one in Nepal. Nepal also, the entire wall, they use lime, mainly lime. And this lime, I'm telling you, once it is compacted, it becomes really solid, really, really so strong. So it is recommended. As long as it has those combination of gravel, those small gravel mix in it. Yeah, it is good. Is it the same thing that you guys use for road constructions as well? You mix it with the soil, right? Yeah. And then, so once you put your first layer, if you have seen this mark, these are barbed wires. Every courses you place, you have to put 2 lines of barbed wire. This barbed wire, it acts as a mortar bed. Mortar bed, like cement. Okay? They join when you are laying blocks. Before you put blocks on top of the other, you put cement bed, not so?
Yeah.
Yes, so for holding the other one. So for us, we don't use cement in the joint, we use barbed wire. So barbed wires, it's able to hook down bags and up one. The reason is, once you fix this, you cannot slide the wall, and it is very difficult for you to remove this wall. The test was done, a building, Earthbag wall was constructed, and then they set a heavy truck from afar, and then they made it to knock the wall. The wall couldn't fall. But if you see the damage that in the vehicle, you can't imagine. This wall, you cannot push it. Once you have tied everything, you have casted the beam, you can't be able to push it. It is really so strong. So, it is better actually to use this than using blocks, because you have got a lot of advantages. Why specifically this is very important in Philippines? Here is known of earthquakes, here is known of floods, here is known of it is also bulletproof, but you guys have a lot of wind.
Wind.
Yes. You call it what? Tornado, right? Is it tornado?
Yeah.
Yes. So there are a lot of natural disasters that comes and affect us. So if you are not living in the shelter that is secured, you can't, you are always, anytime anything can happen. But at least you are sure of the building you are in. You know, just like in Israel, for them now they know that whenever any missile is coming, they have where they do what? They run to hide. Because they know that once they have entered there, they call it bomb shelter, right? Yes. Once they have entered there, nothing will happen. So, to us, Earthbag technology is like also our bunkers, where whenever any natural disaster is happening, whenever we are inside, we feel safe. We feel safe because we are sure that this wall will not fall, even if the earthquake comes. It happens in Nepal. Houses that were built of Earthbag technology, they didn't fall. But high-rise buildings that were built in the cities, all of them collapsed. Are we together? I like having questions more than me talking. So I would want you, yes.
What is the maximum height of the walls that we can use in the
The maximum height.
Yeah, because from the ground level, what is the maximum height of the
Now, this is done differently, depends on, it varies from one country to the other, and then also depends on the project, the nature of the project. Like for example, for residential building in our place,
Ground floor residential.
from the ground floor
Residential, how many?
to the ceiling,
Ceiling, yeah.
yes, to the ceiling, it is a 3.5 for us. 3.5 meters
Meters.
high. You are able to achieve that. But I think here most people like low ceiling, right? Yes. So up to the tune of 3 meters, right? But you can go up to 4 meters high.
To make 2 stories.
Yes, sure. This building we did even. No. When it comes to the storage, we also design the foundation differently.
Wow.
That is not the design for
This is not the design
Only
for storage.
1 story.
This is just for
1 story.
Exactly.
1 story.
Yes. But when you're going 2, 3, the design of that one now with the guidance, I am glad we have the engineer also with us. So this one, they can be able to guide on that. Yeah. But just the same way you design the foundation, this other foundation, whether you're building storage, you do the same here. The only difference is building the wall. Are we together? So, it is cost effective, It is easy covered with a plaster, very, very easy. Sometimes people ask, can this bag really hold cement? Yes, yes, it holds. When we will be doing it, you will know it. It is inexpensive. The major benefit of this, it is local materials used.
Only soil.
Soil. And that is the key one. And then it is also a source of job creation, because local people, it is because in its nature it is easy to learn. So anybody can do this, whether women or men. In all my sites, when you go in Uganda, you will be able to see we have ladies. They are very busy building.
Women who
Yes, all men, they all work because we have filling the sacks. For us, this one, for blocks, they have to first meet the labor for the blocks somewhere, okay? But for us, this one, everything is done the same time. The blocks are being made, the blocks are being carried, and the wall are being laid at the same time. So that is what we have, and it is fast. You don't have to wait. So the speed of construction, it is rapid, because you find this, because the wall is big and it is thick, the wall comes up very fast, and easy to learn and user friendly, and stable, high level of earthquake resistance. It is fire resistant as well. It is fire resistant, because once this soil is well compacted, even if in fact that bugs get removed, the wall will still stand. You see, and it has been proven the strength of these bugs, when it is combined, it is more than the strength that steel gives to the wall.
how much would be the amount of kilos when it is compacted?
Oh,
In one bag,
in
how
one
many
bag,
kilos
it varies.
compacted?
It varies, because these sacks, they are not. We don't cut all of them in the same size. We cut them when the work commences. We cut in different sizes, so it depends. But you cut it in the size that you can be able to carry. So maybe 8 kilograms,
15
10,
15
even
kilos.
others 15 kilos. Yes. So, but it has to be, the weight has to be done in a way that the people who are working find it easy to carry and put in position. Yeah. And then later I will be able to show you some different photos that we have. And then it is environmentally friendly. When we talk about
Even we have still the trees,
the
we have to remain the trees that we will not cut the trees.
no need, unless it is exactly where the wall is going to be, that's when you can. Yeah. But it is environmentally friendly. Think about this. In our place, people use burnt bricks to build houses. These bricks, people cut down trees to burn bricks. And think about the numbers of trees that people cut down. This is destroying the environment. Will eliminate the numbers of cement used in this, because actually this cement, they are really spoiling our soil, our land. It is spoiled. Are we together? We have so many advantages. So I have shared this copy. We may not be able to go through all this, but we can be able to share with you the soft copy of this. I would want to hear more from you. about any question, anything you want to understand, feel free to ask.
Pastor,
Yes, sir.
do you have a diagram, a model for the width of every room?
The diagram.
The width.
Yeah, the width.
Yes, you will be able to see how the walls are.
And how would you connect the beam to the post? All the stuff.
How do you?
Connect the beam to the post.
Do we still have
With
to
the
put
post.
post? I mean column? Column
Column.
post? Do we need to put column post?
Yes, like for this one, we are going to have column
Steel
Right.
made of steel.
Maybe.
Yes, we're going to steel and concrete.
As the column?
Concrete column. We're going to have it.
It's very nice to put,
Especially, how about the bed? It's also made by Starbucks.
The beams we will use steel concrete.
Okay.
Yes, we will still use concrete just like the same as this other one.
okay, it will be connected
Yes.
the post more.
When you reach the beam level, you drive how do you call it? For us, we call it iron bar.
Iron bar, yeah.
Yes. Yeah. So you drive it on top of the wall, and then before you put now your beam, so that by the time you're casting your beam, you cast together with those bars. But in event whereby you have the columns in the building, you don't need to drive those bars. This column will be able to connect the beams together.
Okay.
Yes. Yeah. Thank you so much for that. I don't know if I have. Okay. Yes. You can see how the foundation. This one was done in my project which I did in India. We did it in India. So you can see, we started with
Put stones. Big
the
stones.
stone under, then on top we level it.
How many centimeters?
The whole thing is 35.
35 centimeters.
Yes, the whole of it. Yes, including now the gravel. Yeah.
35 centimeters.
My signal is starting, I think, from here, right? I don't know. It has come back. So now, you look at this. This is DPM, dam proof membrane. Engineers who are in the house to be able to understand this, and those who are well versed with the construction. Do we have this here? It comes in the road. Do we have it here? Not here, but do you normally?
Is it a tarp? What's that?
It is plastic. It is plastic.
Do you have some sample, please?
We don't have it here. Let me get this.
Ano, bigas eh. Okay, wait lang ang kanan.
It's like we use it in the fish pond.
Tarp,
Let me-
tarp. Tarp. Kumbaga, atong mahalon.
It's not tarp.
Let me.
Mag-visit mo yan po.
I think I have it here.
Mula sa kuwan ko, carbon.
Something of this.
Okay, we will see that.
This. Oh, you don't have it here, right? It comes in the roll like that.
Shopee o Shopee.
You will order the shopping. Oh, jump
Yes,
rope.
dump proof, yes.
Jump rope.
Mamaligyan ko na.
You don't have it here, right? Okay, no need to worry. No need to worry. Even if, okay, I am going to ask you a question. What do you guys use here to protect your wall from moisture or water? Yes. Because the main reason of this is the same, protecting your wall from water. So this one is very common in Africa. This is what we mainly use. We fix it in the foundation, like even in the floor. Before we slab the floor, we blade it in the entire floor, and then we pour the concrete on top. So, engineer, maybe for the sake of understanding, you could be able to tell us how yours is done. You use?
The
2 mm? It is a plastic one, right? So you guys are well versed with the 2 mm, right? Is it done in every construction?
No.
So the use will be for the high-rise buildings.
For high-rise building. Okay. Okay. Yeah, but mainly this, we use it to control moisture rise. Yes, in the building. That's the main purpose why we use it. And then so when it comes to filling the soil in the sacks, we use buckets. This one, yeah, people use a lot of creativity in filling the soil in the sacks. We may not necessarily use this. In Africa, for us, we actually now, when we started building, we were using buckets, but then we realized that these buckets doesn't stay for long. So now we had shovel, spade. Yeah, so you just cook the soil direct, put in the sack. Direct, put in the sack. It is easy that way. So you find another team there filling it. One team is just cooking the soil, one person is. We are going to do it practically. That's why before we do anything there, I want us to have this common knowledge together. So that you will be able, when I speak certain things, you are going to understand me better because at least you have got the concept. Yeah. When you look at this is the bags, the ones they have now filled the soil in it. People use, after filling the soil in it, people tie these bags differently, but you're going to see how we're going to tie ours also. So others comes when behind sacks it is a round, oval kind of, and then before you lay it in foundation, to make it easy, you first compact it down. I hope we're going to. Do we have the rampa ready?
Yes.
Do we have it ready?
Compact.
Yes. Okay. Good. So
What would be the tools used for compact?
what would be
The tools are we going to use for compact?
What tools?
the tools? Oh, tools. It is that compactor.
Yeah.
Oh.
Made of wood.
You can design it in some. It is in metal form. Let me. It is up to you, as long as it is heavy enough that can be able to compact the soil. Because I have been meant to know that this varies from one place to another. Let me first. Something like this. Okay. Do you have it here?
Or can we use metal to
Sure. You can either have metal handle or this? This is what we use for. Yeah. So which one do you have? Which one do you have here? Because we do it manual. You.
Just wait. I already made one.
Oh, you.
I did see your model.
You made your own. Very good. Yeah. So anyway.
Pastor Sam,
Yes.
and also in here, it's very hard. It's not easy to, especially there is no rain, it's very hard. That's
It's-
why, yeah.
When there is no rain.
Different way to manage.
So you need to put some water.
Very hard.
Oh. Now this is what happens. When the soil do not have water, we advise you to add water in the soil, but not too much. It has to be just moisturous. Okay? Where, in fact, water should just be as minimal as like 10%, as long as the soil is moisturous.
Here is our command.
Oh, yes.
This is my model.
This is your.
You need to copy our model.
Oh, this is good. It's really heavy. Yes.
Right?
This is what we need. Yes.
You see?
Yeah.
That's your model now, huh?
But
Change.
now, the only challenge is it has to be flat.
Yes, I know. That
Yeah.
is why we need some another metal
Yeah,
here.
you
Flat. Will it,
Aha.
so it will be flat.
Exactly. But it is heavy enough.
Yeah.
Yeah. Thank you very much. This now explain. You can have your own as long as it is.
Very heavy.
This is heavy. It's really heavy. Oh.
That is your place.
Mine in Uganda is also as heavy like this.
Pastor Sam, you use that. After an hour, our body was already exhausted.
Okay. Are we moving well? Good. And then this guy is showing. You see, people uses different techniques. But you see, when you have a big site, showing takes time. Okay? But if you have small projects that you're doing, it's okay. I am going to teach you another way, not showing it. We just, after filling, you just tie. Find another one, you tie it, just like that. But showing, it takes time. So the speed may be too low. Otherwise you can easily get discouraged. That if it's the only way, then yeah. So you apply a lot of creativity. Actually, that's the one thing that is very unique with this. You apply a lot of creativity in it. Whatever that works for you, as long as it can support engineering framework, you're good to go. Okay? Oh, can I have that?
It's not big. Check mo na ito.
Any more questions? Feel free.
Pero bago na rin.
Baboy. Practically good.
Do we have any more questions?
Gusto rin yun. Ito rin.
So, something I want to show here. Just like I told you, many people show this with the needle. Yeah.
Needle.
Yes. You have that needle, right?
Yeah.
Yes.
But how strong is it? So,
Then I will show you the better way than this. This is just to give us rough ideas. But when it comes to practical, we will do it. So, do we have GEI textile that we can put? Yeah. Do we have this here?
Yeah.
It's there. Can we do it in our foundation? That one? Okay. Because since the nature of our site there, it is sloping, it is advisable to use this. The purpose is that number one, it protects the soil from falling, the foundation, and then two, remember when water log is in the foundation, water must be able to access the pipes, these pipes, and then flows out. So you do not want the soil to go and then block these holes that are in this pipe, such that then water log will be in the foundation. Mostly we do this on the site that is sloping, like the one we are doing. We needed to apply this. Yeah. But if we cannot get it, then we have to do gravel all the way on the side. After raising the wall, we have to do gravel. Make sure our wall is well protected. Yeah, but this is optional, and it varies from one site to another. Yeah. This is how the wall is done. You can see our compactor. I told you it is designed in different ways. After putting your wall, you now compact it. And this is able to form a very strong block, very strong and solid, you know. And you see how, because of the AC and the fans inside is cool, with this technology, you don't need this, but you will feel this environment in your house because of the wall. And what happens outside here during the daytime is absorbing the heat. And then the heat will reach inside, maybe around midnight there, but it will definitely be regulated. It will not be like as hot as, you know, the temperature outside. Are we together? So you can see how we have filled the soil in the sacks. These sacks can come in different colors, they don't necessarily mean white. Any color, if you want your project to be unique, you can say any color you want. Yes, because in the factory, these guys have different materials. They can give you anything you need. So, we have women, we have men. This is still the project we did in India. And they were very excited, you know, when we were doing this. Because actually you have this group, you have the group lane. So the activities, people enjoy actually working because it's very simple, very simple. So you see, like our foundation, before we put the wall, we did this, we put it and then we started laying our wall. So after the wall, we folded this to the level of DPC.
Before,
Yes, we'll fold it. Because this one will go inside, we will bury it in the foundation. Yeah. So the wall is protected.
protection for water, flowing water.
Yeah. Yes. This is how the barbed wire is laid. Okay? Because when you see this? Every layer. It has to be every layer. Okay? That is how it is done. Yeah.
It could resist in shaking. Wow,
Yeah?
yeah,
So-
very nice.
In every corner, you drive the river, the wires. Okay? Every corner. Yes. But most especially the sloping area like this, we have to do this.
If that is no base plate,
How about the vertical rebar? What would be
The size, you can use T10,
10?
yeah, 10 millimeter, can do.
So that will be going down?
Yes, it can. When the wall is too tall, you raise up to window level, you drive. Then again, from when you reach the beam level, you drive up to window level, just to enable to tie the entire wall together. Yeah.
Together with the barbed wire? You tie the barbed wire then?
No, you don't. You just drive it. Yeah, you just drive it with the hand. So these are some of the projects that we did in Uganda, and that is how the wall look like. Okay. Pardon?
very nice.
Yeah.
So,
You see, for us, we enjoy construction because our land is flat. It is very easy for us to do the construction. See, that's the same house, the other house.
Is it?
Yes.
The bin?
Yeah, you can see.
The bin?
So this now explains your questions out the beam, reaching the beam level. Even after the beam, we call it over beam, you still use the same.
that is used
So the bin, we are going to use the cement?
Yes,
No.
the beam you use cement.
Use cement?
Yeah. But if the building is not big, others, in some places you can use wood.
Ah, wood?
Yeah.
Too big?
Yes. Yes, you can use wood. So you can see, as I was explaining, you are able to use any design, as you can see. Round building, any angles you can form, you still can be able to. No.
No to worry about earthquake.
No. So when it comes to plastering, it's an extremely important step that will transform ordinary looking back wall into a thing of beauty. Now, when after that, okay, in other places, you see, when you're building these sacks, it really looks nice, just like that. But again, when you plaster, that beauty, that white color, because plaster, this is mud, it definitely darken the wall. But why we do that is to protect these bulbs. These bulbs, it's not supposed to be exposed to the sun. Once it is exposed to the sun, I can tell you,
It will be.
I'll give you only 3 months. You go and rub it like this, it will all go. Okay? When you let this get exposed in sun, the sun, not even water, It is the sand that weakens it more. But once after building and then you plaster it, it will remain just as it is for over 500 years. Okay?
So can we paint that? We can paint.
No, of course you are going to plaster it. No need to paint because you will plaster it.
Using soil again? Or cement?
You will use cement mixed with
Plaster.
sand and then you plaster it.
Plastering is cement.
Cement mixed with sand. That's where you need cement. You need cement. You will need cement to plaster the wall,
Yeah.
casting the floor, and then the beam. That's where you need cement.
So
Okay.
we may put chicken wire.
Yes. When preparing for plastering, you put chicken wire on the wall, and then you plaster. Yes.
Plastering in the cement.
How can we hold the chicken wire?
How do you?
You know,
What's your question?
You know, in making sure that the chicken wire will attach to the walls or what we use.
Okay. When building, you put wire across the wall during when you're building. After every 3 courses, you do some cross. You cut binding wire. When I call it binding wire, you know it, right? You might be having it GI. Yes, for tying this wire that used for tying metal.
Higher wire.
Iron wire. Yes, so you cut it and then you put it across the wall. After every 3 layers, you put. After every 3 layers, you put. We will do it. You will see. Yeah. So that one, you make it protrude outside the wall, such that by the time you are fixing your chicken mesh, you just tie with it. Yeah. So most Earthbag homes are plastered with either earthen, lime, or cement plaster. All work well under certain conditions. Yes, sir. You have some question? Oh, okay. Yes. Use the following information to help you decide what is best. You know, in other places like in India, Walker knows this very well. In India and in Nepal, there are people who don't use cement. They use rice straw. They mix it with mud and then they use it for plastering their wall. They use mud, rice straw. There's a way they mix it, and then they bury it to the ground and they make it for plaster. Because they are running away from the cost of cement and the sand. Because most of them, some of them, they are on top of the mountain. It is very difficult to carry the sand from the valley on top of the mountain. So most of them resort using mud and then rice straw to plaster their wall. Yeah, but of course there are people who do not want to associate themselves with mud. Okay, and then yeah, whatever materials you choose, a good plaster job can transform rough asphalt walls into a beautiful home, and where you can be able to paint it. Once this wall is plastered, it will just be like this other one. You will not know that it is built out of asphalt. You can see. Now plastering. You start by filling the joints, because this wall is always, because the bags are round after filling, so you start by filling the joints, then now you do the plaster. Okay? This is the rice straw that they were using are using rice straw.
Chicken wire is
You have seen the chicken wire, right? You have seen the chicken wire.
Yeah.
On the here is not seen clearly, but when you look at it from here, you can be able to see the chicken wire. Oh, sorry. Yes.
Wire in there, adhesion of the plaster.
Do what?
On what cases would you want to hang like a wire, a chicken wire, to support the adhesion of plaster to the bags?
Okay, I've not got you right.
How important is that?
How?
How important is it to do things like hang chicken wire to the bag walls?
That one now, it is done after you have raised your entire wall.
Okay.
Yes. And then you now start fixing it. Remember, you have put those wires, and then it will help you to tie. So chicken wires is always done after you have built the entire wall complete. Then now you put it. Yeah. So there are some places, if you want to use wood instead of metal, there are two ways that you can do. Number one, you can use inbuilt or after you have built your wall. Like you can see this one with our metal frame. Before we started raising our wall, we had planned our project. We already have the doors and the windows. They were ready. So what we do, once you reach each level, you fix the doors, you fix the windows, and you keep raising your wall. By the time you are finishing your wall, you find the doors are ready, even the windows are ready and fully fixed. But you can also decide to raise the entire wall and you fix the doors and windows later. But the most important thing that I want to explain there is how you fix your doors and windows in all these levels. For example, when you're using this method which we did, you want to fix your doors and windows before. This is what you do. You have to fix, if you're using wooden frames, you have to fix the Velcro plate. You nail one side on the wood frame, then one side you have to create holes and you drive nails in the bags. But with now my experience, this takes time, a lot of times, and sometimes you would want to take too much time in constructing the house. So the best way is to build the entire wall, and then you fix your windows and the doors later. Okay? And we're going to use that method on our site here, and I'm going to show you how to fix doors and windows. But in case you want to fix your doors and windows during the construction, you have to use that method. So, and you have to keep doing this after every 4 courses. Okay? We have got that right. Any question in line of fixing doors and windows before I proceed?
By the way, Pastor, if we will use a steel in our door jamb, window jamb, can we apply that?
Yeah, it works.
Okay.
Yes, for the steel you just weld that one, the other, the horns comes. Yeah. Yeah.
Can you use steel?
Yes. It works as well.
Okay. It's easy than to use wood.
Yes, true. I also prefer steel. So because like this method, when you're doing, you have to support your doors, your windows. So all these also, the movement in the site becomes very difficult. That's why it is the best way. The best way is to first raise your entire wall before fixing it like this. Yeah.
Lord help.
Good job, very good job.
Yeah. Our roof. This is the other house you saw which we did, and we first did rough plaster outside to fill in our joint, and then and the roof, you can design the roof. In Uganda for us we use, you call it lumber, right? Wood? Yes, we use wood more because steels are still very expensive, but now people are now coming up. Lots of people now are preferring using steel instead of wood. So I believe
If you use your wood, so probably you will arrive at 10,500 views.
pardon? Oh yeah, you are right. Yes, because
But
wood,
if you use
Yeah.
wood,
So
so
we,
wood.
for me,
Yes,
I rather to use steel
steel is better. Actually, I prefer steel.
because wood is very expensive here.
expensive.
Very expensive.
It's
Wood.
very
Wood is
expensive.
very expensive here.
Yeah.
That the
We use steel.
Yeah, yeah. Because when you use steel, you don't need all these.
Yeah.
Steel, you even reduce the number
Reduce.
because steels are stronger than the wood.
It's strong, stronger enough.
Yeah, so actually we spend more money in roof than actually the wall.
Actually, go for lumber is more cheaper.
yeah.
But it's really,
That's
if you
why
not long last, the
it's
disadvantage, you will suffer from your lives.
Yeah.
You want to last long.
If we last long, we will use steel.
Steel, yeah, steel is better.
If we-
So now, when you're using steel, this is what you have to know. When it comes to wall plates, you have to bear in your mind how you're going to fix your wall plates to the wall. Okay? So during the time you are casting the beam, you have to insert those hooks inside your beam. You cast it because here you have a lot of heavy wind that you don't want a scenario whereby wind has come and has carried the whole of your roof. You know. So during the time you are casting your beam, you need to fix those hooks inside the beam and let it protrude. By the time you are placing your steel as the wall plate, those hooks you bend it and you tie it, on top. Like when your wall plate is here, then you can tie and then weld it. It is much more easy that way. Right, engineer? Yeah. I think that's also the same way you do here. Exactly. Yes. Yeah. Assurance of the quality and standard. This, we are not just doing things that was not tested. This has been tested way back and has been proven and has been done and people have experienced it. So we are not gambling or so many people have done. Earthbag material standard, the bags have been tested and ISO in 2001 certified for packaging. Average bags duration is 500 years when sealed. That is very key, okay? When sealed. when plastered, once it is recovered,
500.
500 years.
Wow.
Okay? The structural calculations are the structural calculations are created by Staff Lances, Systematic, and then structural engineers. A lot of people came, engineers, and did this. And on-site trained under construction specialists, supervisors, all construction. Now, this is very key. Like now, I have come to do the training. This is my prayer for all the team we have here. Sometimes we spend a lot of money coming. Actually, like my coming here, Pastor and Ali, they have spent a lot of money, and then is to make sure that we come to do this technology transfer. This is what we expect from you. Before I started building this technology, I was also trained. I was not the only person they trained. We had 50 engineers that were trained on this. But out of the 50 engineers who are trained in our countries, I'm the only person who picked interest on this. Why? Because of there are so many things that people believe in. For example, people are used to conventional method. So for certain reasons, some people feel if they get to know this, maybe this will take over their job. The truth is that I'm telling you, I did civil engineering. I also build conventional methods. But I'm telling you, Earthbag technology, it is dominating conventional methods. And so there are people who used to get a lot of money in the conventional way. So they do not want now to hear any new things coming up. So because of this, it makes some people come and discourage you. Because for example, when you are talking of, we're talking of a building made of sacks, the people are sacks, and then people will be wondering, soil, how will it last long? So the number of people will come and then discourage. And these are kind of words that makes people lose interest. And now, once people lose interest, you make our efforts, you know, it becomes useless, you get. But think about this. If we carry this forward, for example, now we are going to do this, what I expect from you is that the heart, first of all, have a heart for this. Believes in it. And you will be the one to testify. You will be the one to testify about the benefits of this technology. Let's have a free mind on this during this process. Why? Because later, I would want to see you doing it. Okay? I would want to see you doing it now by yourself. But that will only happen when during this training session and during the practical session, you are going to commit yourself, your time, and make sure I have to get every step of this. That's when you will. And the next time I can guarantee you will be able to do this. It looks very simple, but also a little bit tricky if you don't put all your heart in it. So my prayers for you, as we do this project, let's own it. I would love to see you coming to me, how do we do this? I would want to see you getting involved in it and do it practically. We can only learn how to build this technology when we do it practically. And once you have done with one side successfully, the other side will be much more better than the first one. And then your third side also will be, you know, That will be your experience. Praise the Lord. Yeah, so
Mr. Sam, can you supply to us the bag?
these bags are available in Philippines. It is available, yes. Yes, it is in Philippines. Yes. It is available, so you don't need to worry. These bags are here.
Yeah, we are worrying how can we...
No, they are here. They are here.
Shopping.
Yeah. So these were different tests being made to test its behavior, before people began to implement it. These were different tests that were done. Its behavior, the tensile cracking, the compression test, all was done.
Wow,
See,
it's nice.
that's now the complete building. Okay?
Tinatamat yung pagbiwan na.
Anak, hinog man.
Di sa tamat. Silutan, nasa tamat.
All those buildings I did, in Uganda. Yeah.
In India.
Any design you can be able to achieve this.
Oh, nice. It's beautiful.
Hindi lang sa baboy.
These ones are done in Nepal. These ones, that is the Nepalese style. The roof are low.
Inside. Dito dasa.
You see, this is the floor.
The floor is
Yes. This is how the floor is done. Down the wall is made of Earthbag. So, when we started, when I got trained on this, we were still using long bags. But as I kept on doing it over and over again, we realized that using long bag when you're doing this, you take more days in the construction. So we derived so many ways. We started cutting these bags into smaller pieces. You feel the soil, like the other first one I showed you. It makes it more easier to carry, put in position, more cut. But this one, you see how this person described. You have to go like that all around the building, every layer. So it was very difficult. But now, the concept you are getting today and onwards, it is a modified one and very easy.
Easy to carry.
Easy to carry.
How about this bag? If we can make this bag, we don't have problem here.
Right, polyethylene.
Yes, sure. He was
This
telling
is-
me
This,
because
this
is
material
the
is
same
the same with this.
Yes. It is the same.
And this is only,
Only
Right.
the size.
The size is
Only
big.
the
yes,
The size is
the
big.
size is really good.
Bigger.
You can cut it half.
Yeah.
Ah, okay. Yeah.
Oh, the same this.
May asa nakapalitan eh.
In bakery. It's only piso.
Piso?
Piso.
So if you need
Order.
big one
Silver is a custody.
and you have most of these bags, I have no problem. Deal. Okay? But
That is bigger, too heavy to...
Look at that one.
Cutting normally.
Look at that one. Much bigger than this.
okay, now when you feel the soil in it, the
Heavy.
size will reduce a bit.
Oh,
Also.
right.
Yeah, it will reduce.
It's
a bit.
only 25 kilos.
But the reason why the other one it is much easier. It's because you cut it any size you want, but this one is limited. Okay, this one you are limited because they have already given you the size, and sometimes when you cut it, to tie it becomes very difficult. Yeah, that's why the other one would be much easier. It's not hard to get the other one. It's just a matter of planning. Once you plan, you make order in advance. But this one, as long as you are okay with the size of the wall,
Very.
yes, like it's just like also the conventional method. There is what we call English bone, where you want double wall. So you find people are building double wall using this. But of course, you know you're going to spend a lot of money. Yeah. Thank you, Pastor. So with this, you can see how tall this wall is. You can as well have for like stores. There are some big stores that the wall has to go high. So people are designing this. This was constructed in South Africa. But you can be able to have also more storage, high with this. But the design, we have to sit down and design it based on what you need. Okay? But for the normal residential building, it is okay. You can just have some simple plan draft, and then you can start your site. When we read the other advantage that it is fire-proof. This house was burnt. You can see the bugs got burnt. This is now the real soil. When it is compacted, it will remain, but the bugs is removed. So meaning the wall cannot fall, still remain just as it is. Yeah.
So the soil that we use is wet or dry?
Wet. Yes, it has to be moisturized, and then you compact. Not too wet. Not too wet. When it is too wet, it is very difficult to deal with it. But it has to be just moisturized because you will compact it. Yeah. This is how our floor is done.
The
This is
floor.
the foundation, the floor. This is the stone. This is the wall, thick wall in the foundation. So I think this is the same way you do your flooring here. Yes, then later you blind it and then you cast it with the concrete. Yeah.
Okay, thank you.
Okay. So it goes the same way.
Okay.
Okay.
But the foundation is cement.
Cement?
No.
No. You see, this is wall. I have covered it with the DPM, the other black thing. We have covered it. Yes.
Now, the floor we are going to use cement in making.
Yes, cement. Yeah. We use cement.
No more bars. No more bars.
If you want, it depends. There's some places in front of, so you can use, after putting this, you put BRC, right? You have it. You have it here. You do it, right? But it depends. Like in our place, BRC is very expensive. So some people just decide to begin on it. Yeah.
So the thickness of the is 6 or 4 thickness of the wall.
The thickness of the wall varies also. In Uganda, for us, because people want smaller wall, not like big one. So we have reduced it to, the bags comes in the size of 30 centimeters,
4 inches or
30 centimeters. Then after filling the soil and compacting it, it comes back to 25 centimeters.
25 centimeters?
Yes, 25 centimeters. But then others use even up to 45 centimeters. So it depends on what you want. Some people want to build wall fence, and wall fence you want it to be strong. You can use like 45. Yeah. See that it started?
So can we use that like,
Yes.
like that also?
No,
No.
no.
It's
Like that.
Yeah.
Yes, it has to be like that. You're going to see the roll from the side there. I'm about to finish. We're about to.
Baka,
So we can plumb. You see, like here, we plumb the corner, we use the plumb board. So these are the guys that I have trained in Uganda, and they are doing their job. You see the long sacks? It is very difficult to fill. When you make it too long, you can see. But there are certain areas when you reach, you would want to have a little longer bag. So that's why it is advisable to use the bags that has come in rolls, because you are able to cut any size whenever you want it. But when you use the size of the bag that is fixed, then you are limited. You can't make certain decision. Yeah. All this, yeah,
finish.
yeah, that's the finished one. This one, the one we have already plastered.
All those plasters? Oh, plaster wala.
We have already
Oo
plastered.
ba, ang sandbag na ulis dito? Sila nga mag-itubog ka ito eh. Mga kahit pinwari, magkaka, diba?
Oh.
Tapos outside, so dito rin.
Yeah, this is just a simple way of you doing the soil test.
Wow.
Yeah. Just pick the soil, hold it in your hand, and that is how you know whether your soil has the good texture for this technology. As long if the soil is able to hold itself, just like this. Clay, yes. As long as it's able to, yes, you can easily see it with your hands. It's just a simple way of testing it.
But here,
Ito na mabungkay sa weak soil.
last month, nag-test sila sa
Yeah, this is how we tested it.
Dire sila Brian. Morning na. I-test. Ang soil, ang lime,
Oh, lime.
o ang combination sa duha. So,
The best one is the combination.
Yeah.
Yeah.
Dark chocolate, milk chocolate, o
Yeah.
So, maayo ang lime soil, ma'am. Maayo ang lime soil, no?
Yeah.
The best soil is lime soil. It's good.
Lime soil, yes. Soil, lime, mix together.
I mix soil, lime.
Yes.
You mix.
The limestone.
If you will only use the lime soil, would it be good?
Yes.
Be good? Don't need to
If it
mix.
is of smaller particles, okay, limestone, smaller particles, mixed with the soil, it is okay. Okay, that turns out to be what we call maram. This one that people use in the road for compacting, the
Okay,
road.
because limestone is very hard. Very fine.
Limestone, right?
Oh, yeah, limestone.
What's the size?
Depend.
If it is bigger, you don't need it because it will not work out, and then it will
Here in-
tear your bags
here-
as well.
Here
Yes.
in Medellin, limestone are good. Yeah.
Okay.
Very white.
It's very wide.
Yeah, very
Okay.
good. The limestone
I
here.
have had-
Can it hold itself?
White house.
I-mix.
They are
Ay, nag-testing man ni diri.
Yeah, I think majorly some soil that form on balls when squeezed, still shatter when dropped, they can feel good because they have a lot of sand, or feel smooth because they are smoothly sealed. Either should have clay added so that an earth bag will hold together. The main thing is it's holding together, yes. This will greatly reduce the cost of the reinforcement, and this will greatly reduce the cost of the reinforcement. That's if needed.
At times I was balanced.
Okay? Yeah. So, I'm done. This is the end of our class work. Yeah. Thank you. So, any more questions?
We will ask them in the
In the site.
During the
Okay.
actual
May I request you, maybe now you pray for us so that we conclude this session. And now this is what will happen. In the site, we're going to have 2 teams, actually 3. But for today, we are going to have the team filling the soil in the sacks, and then the team who are going to. Pastor, have they brought for us stone already? Oh. Okay, we will go and pick the one that is available, and then. But if you could make a follow up, if they can bring for us, it would be able to also help. Yeah. So we have the team, other team putting the stone in the foundation, then other team going to fill the sacks. That's what we will be able to do today. Then tomorrow is when? Today is Friday, right?
Friday,
So Saturday tomorrow, we are going to